Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students in functions and relations who are working on the year-end summative. This is question number 3. After a tee-off, a golf ball lands on a sand trap 1 meter below the level of the ground. The golfer hits the ball and it follows the function. So here's the equation of the function, where h represents the height from the ground level in meters and t is time in seconds. So when I look at this equation, I can obviously tell that it's a quadratic equation and that it is a negative parabola, which makes sense because it's a golf ball, so we expect it to go up and come back down. So what do the h and t intercepts represent? So let's think about this question just a little bit. So what we have is we have a golf ball that lands in a sand trap 1 meter below the level of the ground. So here's the ground, roughly horizontal here. And then there is a sand trap apparently here. And that sand trap is 1 meter down. And so the golf ball lands in the sand trap. And then the golfer hits it and it follows a parabolic arc, presumably something like this, until it hits the ground, like that. So that's what's happening in this question. And it says, what do the h and t intercepts represent? So we'll find the h and t intercepts in a second, but let's just make sure that we understand where they would be on this graph. An h-intercept is going to be something that looks like this. So it's going to have a 0, and then it's going to have a number over here. So the h-intercept is where t equals 0. So when the golf ball starts its journey, so at the very moment where we start, hitting the ball, where is it? Well, it's right here. It's in the sand trap. So the h-intercept is the initial height of the ball. And it's pretty easy to find that from the equation, and you don't even need to do any calculations, but I will anyway, that when we start using this equation is when time equals 0, and at that moment in time, the height is -1. So the height intercept, so the h-intercept is at 0, comma, -1, and what does it represent? Well, it represents the starting height of the ball. And most of the time, you don't have a negative starting height because most of the time things kind of go above the ground but not in the ground. But because we start in a sand trap, which is below ground level, that's why we have a negative starting height. And I'm going to put that in my explanation here. Oops, not ground height. I want it to say ground level. So it's negative because it starts below ground level. Okay, so that one's pretty straightforward. The t-intercepts, so the t-intercepts are points that are going to be like this. So they're going to be points where I don't know the t value yet, but I know the height is 0. So in this diagram, the height is 0, meaning ground level, right about here and right about here. So those t-intercepts are going to represent when the ball is at ground level. And again, we're going to get 2 of them. One of them very soon after the ball is hit because it only takes a meter and the ball is going to go up pretty quickly. And the other one when the ball comes back down and hits the ground. So let's actually do those calculations and figure out where those t-intercepts are. So again, here's my equation, and I want to find the t-intercepts, which is another way of saying I want to find the roots. So I have to let the height equal 0. So if I let the height equal 0, I get this equation, and then I just need to solve for t. So how am I going to solve for t? I think because it's a quadratic, I'm just going to use the quadratic equation. So t equals -b plus or minus the square root of b squared minus 4 times a times c, and all of that gets divided by 2a. And again, if you haven't had me as a teacher before, this is how I like to start my complicated equations, which is by writing the equation but with blank brackets. And now I go back and I substitute into those brackets. It just helps me make sure that, first of all, I've written the equation properly, because it's easy to say -b plus minus and make sure. And then also to make sure that I'm not my brain isn't focused on writing an equation while also kind of my eyes are drifting up here to find the letters. I've just made too many mistakes doing that, so this is how I've learned to control all those silly mistakes. So negative b plus or minus the square root of b squared minus 4a times c, and all of that divided by 2a. So let's do the math. Negative 15 plus or minus, and then this is a good calculator moment. So 15 squared. Should have calculated this in advance, and now you get to wait while I type stuff into my calculator. So 15 squared minus bracket 4 times negative 5 times negative 1, close bracket. So that's 205 under the square root sign, and the bottom of the fraction is negative 10. So I'm going to split this now into two different answers and calculate what the square root of 205 is. So the square root of 205 is about 14.3. So one value for t will be negative 15 plus 14.3 divided by negative 10. And the other value will be negative 15 minus 14.3 divided by negative 10. So doing both of those calculations, I get one t value of 0.07 and one t value of 2.93. And again, if you think about the diagram, one of my t values is not very long at all. It's 7/100ths of a second, so that's this one. And the other one is not quite 3 seconds later, and that makes sense. I've watched a few games of golf in my life, so that makes sense to me. So those are the t-intercepts. And I know it didn't say find the t-intercepts, it just said what do they represent, but I've already read what B and C say, so I know I'm going to need that information anyway. So there's my t-intercepts, or to write them properly, 0.07 comma 0 and 2.93 comma 0. And for full marks, I might put beside each one specifically what it means. This is the ball traveling up out of the sound trap, right? That's the very fast, short time one. And this one represents the ball hitting the ground. So these are the time references when these two events happened. Okay, so then it says, boom, oops, next page. So we answered A, and it says how long is the ball below ground level to the nearest hundredth of a second, and how long is the ball above ground level to the nearest hundredth of a second. So let me just draw my little diagram again. There's my sand trap, isn't it lovely? And there's the ground level, which represents a height of 0. So here's the ball, and it goes up and then back down. So well, we know that the moment that the ball reaches ground level, so I'm drawing like an imaginary ground level. So when the ball is right here, that's 0.0 seconds. And when the ball hits the ground, it's 2.93 seconds. So how long is the ball below ground level? Well, it starts at ground level. That's time equals 0. And then it takes 0.07 seconds to get to ground level. So the answer to B is just 0.07 seconds. How long is it above ground level? Well, the entire duration of this path from here to here is above ground level. So starting at 0.07 seconds until the ball hits the ground, it's above ground level. So I will find this by subtracting the total time that the ball is in the air from the time where it's below ground level. And if I do that subtraction, I get 2.86 seconds is the time that it is above the ground level. Okay, I hope that was helpful, and I'll see you on the next video.